Leetcode. In this problem, we will go over house rubber. And so basically in this one, our goal is to get the maximum amount of money that we can rob without alerting police. So when do we alert the police? We alert when we are robbing two adjacent houses. So we need to skip all those adjacent houses. And given nums is all those amount of money in these houses. So let's go over this example. So if we start from house number 1, then we're skipping the adjacent one. So 1 plus 3, that is 4. And let's say the other option is like 1 plus 1, that is 2. And then other options like starting from the second house, 2 plus 1, that is 3. And out of all those, the maximum was 4. So that's why we are returning 4 from here. So this is an optimization problem. So this is we can solve it with dynamic programming in here. So first thing first, what is our objective function? So our objective function is to find the maximum amount of money without alerting the police to rob a house. So this is our objective function. And what is our base cases? So let's say if there is one house, what will be the amount that we will be getting from one house? Just we'll rob the first house, whatever the amount we'll get from there. What about if there are, so another one is like 0 house, right? Then we're getting 0 money out of it. And another one if there are 2 houses. So that's where it gets interesting, because now we have 2 houses. Let's say 1 and 2 right here. So in first house we have 1 amount of dollar. In the second one is 2. So we need to rob the second one because it's the larger one. So for that we need to choose the maximum out of the first house and second house. So from here we can come up with our transition function. So our transition function will be, so we are choosing maximum out of the current house that we are looking at. And when, let's say, if we are at this place right here in our current, then we cannot go to the adjacent. We will go to the one skipping that. So that is going to be so when we are in our function, we will save all those maximum amounts, and we need to go back to, so say we're here, and from our we'll have this function right here will be holding the highest amount robbed, basically. So if we are looking at the current house, let's say whatever the house in here, even like 1, then from our maximum amount that we could rob, we will look back, like skipping the adjacent house next to it, and we'll go and grab the maximum amount and try to combine them and see if it is maximum. So and we are comparing it against the previous one. So out of previous one, because like there could be cases when we are looking at one right here, and from our function where it is holding the maximum amount of money for each house. We will go back and see if it is um, bigger, if it's in a not comparatively to here the previous one, and we'll be updating our function. So this is a bottom-up approach, bottom-up dynamic programming, because we are relying for the previous calculated sub solutions, and our solution will be here in our function. So this is holding the maximum amount of money. So let's jump into coding. So we'll initialize our array. And for that one, it's going to be num's length. So our DP will be holding the amount, the maximum amount that we could wrap. And in the end, the last element in our DP will be holding the maximum amount that a robber can rob without alerting the police. So now it's last index. So let's do the calculations in between. So let's define our base cases. So when we are at 0, that means we can only rob one house. If we are at 1, that means we have 2 houses, so we need to choose the maximum out of them. So we have a house 0, and then we have a house 1. Now we need to take care of in cases where num's length becomes 0, because like if we don't take care, we're trying to access in the 0 base and 1, so we need to take care of this type of cases. So in that case, if the num's length is 0, that means there's no houses, so we'll return just 0. And in case if there's only one house, then we'll just return the houses amount. Now let's go over our occupation. So from here we can start from 2, because we take care of up to 1, up to 2, 0 and 1 are covered, until length plus plus. And in here we will just use our transition function. So our transition function is saying that dpi will be holding the maximum amount of that was robbed. So we are comparing, we're trying to get the maximum out of it. So with this current house, we'll look back, skipping the adjacent house, and we'll compare with TP. So now when we are taking the current number houses amount, and in our DP we'll be holding the maximum amount of houses that was robbed, and we'll take 2 houses back, the second one, so we'll be skipping the previous one, taking the second previous one and adding it, and then seeing if their amount is higher than the previous one. So depending which one is the higher, we'll be updating our DP array. So in the end, the DP array will hold the maximum amount. So let's run our code. Let's submit it. So for time complexity is O of n, where n is all elements in our all those houses, and space complexity we are using extra space, so this is also O of n, where n is all those houses.